Hello everyone. So today we are going to cover quicksort and the problems solved using quicksort. So recently I made an article in LeetCode and which got a good response. So I thought of making a video on how quicksort works and how the problems can be solved using quicksort logic. So now our quicksort is nothing but helps us to sort the array like any other sorting algorithm. Here the hero of our quicksort is pivot element. So what is a pivot element? A pivot element is something that any value from the given array, whether it can be the first value or last value or any random value from the given input, and we take it after every pass, we place the pivot element exactly where it has to be. How exactly where it has to be? It just put all the elements or values less than the pivot before the pivot element and the values greater than the pivot after the pivot element, and bring the pivot element and place it exactly between the numbers less than pivot and greater than pivot so that its position is fixed. After that, we don't have to change its position. We can concentrate on other elements and we fix some other element again as our pivot and place it in its actual position until the complete array is getting sorted. So now consider this example array having some random values. Now let's fix 10 as a pivot. So now we are choosing the last element or the last value in our array as a pivot. You can either choose the first value or any random value based on where you are implementing your quicksort. So now having our 10 as pivot, which are the values less than pivot will be placed before 10. That is, the only value less than 10 is going to be 6. So we are placing 6 first, and then all other values are higher. So we are going to place the other values and 55 later, and finally place our pivot element at exactly where it has to be. So now this position of 10 is fixed because the numbers less than 10 are this side, greater than 10 are at the other side. We can take this and sort it separately. We can take this part and sort it separately, but 10 found its position. It won't change again. So after one pass of the algorithm, it looks something like this. That is 10 placed here, and all other elements are placed in a different way. And next we are going to choose 15, that is again our last element as our pivot, and place it exactly where it has to be. So where 15 comes? 15 comes after 10 because 6 and 10 are less than 15, and from 23 all other elements up to 55 are greater than 15. So now the place of our 15 is going to be between 10 and 23. So yes, it is placed after 10, but 23 moved to the last position. We are going to see why later, but now 15 found its position. So now we every time choose a pivot and place it in its actual position where it has to be until the array gets completely sorted. So now our 23 is going to be our pivot. So 23 will be placed after 15 since 23 is less than all these elements and greater than all these elements. So now placing 23 at its position, it came after 15. So now 117 is our pivot. 117 is greatest of all. So the actual position of 117 is going to be the same. So 117 is placed. Since it is placed in its actual position, we are moving one step forward and take or consider 55 as our pivot. Now 55 is greater than 23 and less than 87. So the place of 55 is between 23 and 87, and it is placed. Now the array is completely sorted. So this is how we gonna choose pivot element every time and place it in its actual position till the array gets sorted. So this is the logic of quicksort. So how it is going to be working programmatically. So now let's start iterating our given array by having two pointers I and j starting at our initial positions. Now job of I is to remember where the numbers less than the pivot ends. So if you're not getting it, you're gonna get it after one pass. The job of J is to scan the array. Every time for every I, it scans the array. So now our pivot is 10. We are going to consider our element at J and check whether J is less than pivot or greater than pivot. As we know, after every pass, our pivot element will be between the numbers less than pivot and numbers greater than pivot. In that case, we are going to compare our value at position J with our pivot element, whether it is less than or greater than. So now here 15 is greater than 10. In this case, it has to come after the pivot. So we are simply ignoring and moving our J to 23. So checking again, 23 is again greater than pivot element, which is 10. So we are moving our J again. So 117 is again greater. So moving our J again to 87. 87 is again greater. So moving J to 6. So now 6 is less than 10. In this case, 6 has to come before 10. So now we have our pointer I. I said the pointer I's job is to remember where the numbers less than 10 ends. So now we have to switch or swap the value at J to value at I. We will know after two passes why we are exactly doing it. So now the array becomes 6, 15, 23, 117, 87 and 55 swapped to the place J. So now 6 becomes 55 and finally our pivot 10. So now our pointer I is at 6 and pointer J is at 55. We swapped, swapping is done. So now our pivot, and we don't have any more elements left after J to push it before 10. So our iteration ends here. Now we have to place our 10 between the elements less than 10 and greater than 10. In this case, I said the job of I is to remember the place where last element ends, that is less than 10. Here, the last element which is less than 10 is 6. So we have to place I after 6, that is the position I plus 1 is the actual position of our pivot element. So in this case, we are going to switch or swap our pivot element with the element at I plus 1. We don't care whether it is greater than or less than, but this is the place of 10, our pivot. So our pivot want its place. So we are going to switch their places. So now the array becomes 6, 10 and the 15 was at I plus 1 position, which was shifted to the rightmost cell where our 10 was, and 10 occupied its actual position. So now after one pass, our pivot 10 moved to its actual position. Now our pivot is going to be 15, that is the rightmost element from the given array. So now 15, to start from 15, we are iterating our I to 10. So now let's start our second pass by having our I at 10 and J at 23 and our pivot is 15 now. We have to check whether any elements are there left than 15 and we have to switch them before 15 and greater than 15 stay after 15. Check the element at J is less than or greater than 15. 23 is greater than 15, so move our J to 117. So now 117 is again greater than 15, so again move our J to 87. 87 is again greater than 15, so finally moving our J to 55, which is again greater than 15. So we don't have any elements which are less than 15 that has to be pushed before 15. So now 15 has to occupy its actual position. Where the actual position of 15 will be, it will be at I plus 1. Because clearly 10 is the last value which is less than 15. After 10, that is from I plus 1, the values start increasing than 15. So this is the position where our 15 has to be placed. So we are switching the value at I plus 1 with the pivot value. So we have to swap the value at position I plus 1 with pivot. So now the array looks something like this. that is our 15 placed here at our position I plus 1 and 23 switched to the last position. Now our 15 is going to be I, and next element is going to be j, and 23 is going to be pivot. So we have to check or scan using j whether any elements are less than pivot. No, nothing is less than pivot. So now it's time to switch our 23 to I plus 1, that is after 15. So now 23 is placed after 15. The next element was 117. 117 was exactly placed at where it was. So next element was 55. 55 switched to this position after 23, and the array is sorted. So this is how our code works. That is, we have two pointers I and j, where I remembers the place where our last decreasing element ends and j scans the array. Every time it scans, it swaps with I and j, and final swap will be between pivot and I plus 1. So our code looks something like this. As I said, we are going to assign our pivot as array of right. It depends on where you implement your quicksort. It can be array of left or any random number or array of right. So we iterate j through the array from left to right pointer. If my value at position array of j is less than or equal to pivot, then swap it with I and increment I, and find it swaps every time it finds the lesser element, and final swap will be between the pivot and the number at I plus 1. So this will sort our algorithm. This is how our quicksort partition will look. So the overall logic is, for every iteration we take a pivot and place it exactly where it has to be, and after the iteration, after we place the pivot, all the elements less than pivot will be to the left side of pivot, all the elements greater than pivot will be to the right side of the pivot. So now we understood how quicksort works. So the time complexity of quicksort is going to be big O of n log n for best case and average case, and big O of n square for worst case. Quicksort is said to be the fastest algorithm out of all sorting solutions existing, if it is a best case. So how does it happening? Because we use divide and conquer. So now the same elements, based on the pivot element, the array will be split into two. So first our pivot was 10, so it splits before 10 as one array and after 10 as another array, and sort them separately and then combine the result. So now this array will be separated based on 15, 15 separated, and greater than 15 elements are separated. Same way, based on 55, the elements less than 55 will be separated and greater than 55 will be separated as a separate array. So every time we find a pivot, we place a pivot. Based on the pivot element, it divides the array into half. By doing this, it is performing in n log n time for best case. When it comes for the worst case, when we choose a bad pivot. So what is a bad pivot? In this case, consider this array. It is in decreasing order. So we choose our 1 as our pivot. So in this case, as we discussed, 1 will be placed exactly where it has to be. So if we place 1 at its actual position, 1 will be coming first, and then comes 6, 5, 4, 3, 2, 7. So now it chooses 7. It scans the complete array to find there is no elements greater than 7, and then it pick 2 as a pivot and then scans the complete array to place the 2 at its exact position. So every time it scans the complete array of size n, and finally it ends up executing in at n square time complexity. Other case is if we choose 7 as a pivot, which is the largest element. In this case, again it is going to take n time to place it at the last, and then 6 to place it at the last but 1. Same way it iterates the complete array to place the elements. In this case, it is a bad pivot. So it is going to take big O of n square time. Instead, if we are not choosing a bad pivot, if our pivot is a good pivot, in that case, we are going to execute this in big O of n log n. So what is a good pivot here? For example, if you choose 4 as your pivot, it is in one pass, it is going to switch all 1, 2, 3 to front, and 4 will be in the middle, and 5, 6, 7 to the right side. Or it may be in different order, but it places every time. So again, it further divides and sort quickly, and further divides and sort quickly. In this case, if we choose a good pivot, it is going to execute in big O of n log n for the same given example. So choosing the pivot is based on where we implement the quicksort. So our code for divide and conquer looks something like this. That is, every time we're gonna use our partition algorithm which we saw previously to find the pivot element or the position of the pivot element, and based on the position of the pivot element, the quicksort algorithm is gonna take left to pivot position -1 as one array, and pivot position +1 to right as another array, and sort them separately and finally arrive at a result. So now we understood how quicksort works and what is the partition function and how divide and conquer is applied and what is the best and worst time complexities of quicksort. Once we have learned something, it's time to apply that on something and understand how exactly it is useful. In that case, we are going to see few problems where we apply quicksort's logic to find its solution really quick and make it work faster. To get that, wait for another video which I given in my description. You can check for the examples that uses quicksort to work on them. So thanks for watching. If you like the video, hit like and subscribe. Thank you.